Good day, I am Uchechukwu Nchaku and I welcome you to this short video of our demo on interpreting many objective feature selection solutions. Now, beginning with the data set, we first of all carry out some pre-processing in order to clean up the data set and get it ready for classification. However, in this clean data set, we could also have redundant or some irrelevant features. So we have to further pre-process the data set through feature selection to identify the relevant features in the dataset. Particularly, we focus on many objective feature selection, which is a type of feature selection that simultaneously optimizes for 4 or more objectives. And the result of this is a set of solutions. A solution is simply a subset of features. So this could be a subset with 1 feature, or 2 features, 3 features, etc., depending on the size of the data set. And each of these solutions is associated with some objective values. The big question remains, how do we choose a final solution from this set of solutions? And we show this in our dashboard. We focus on a use case of a diabetes data set that has 60 features and over 100,000 instances. We use 6 objectives to perform feature selection, and the outcome are 52 solutions. Very often, solutions are presented in a tabular fashion, as shown here. And based on this tabular representation, how would you choose one final solution? There are several important questions that have to be answered in order to make this decision. The first question is, what objective should be considered as the most important, or second most important? How do we rank the importance of the objectives? Based on this, how do we rank the solutions to identify the most important solution? And then on the feature level, considering the individual features, how do we identify the feature that would contribute most to the classification problem, or the feature that has been selected the most based on the solutions? By answering all of these questions, we're able to make this final choice, and our dashboard answers these questions. In our dashboard, there are 5 representations, as can be seen. The first and the third representations focus on the solutions. The second representation focuses on the objectives, while the fourth and the fifth representations focuses on the individual features. Based on the objectives and their values, we are able to rank these objectives by assigning them weights from their range and their standard deviation, and we see that the subset size is the objective that should be considered most, and the equalized odds is the objective that should be considered least. Using these weights of the objectives, we're able to rank the solutions. And this solution that contains about 10 features with this 0.52 accuracy is ranked first. So this is the highest ranked feature, the highest ranked solution. And the rank continues right until the end. We can also flip the rank to see the solution that has been ranked least. On the individual feature level, we see that the primary diagnosis diabetes has been selected 51 out of the 52 solutions. So this is a feature that is definitely very important and should be considered for the classification task. Using the Sharp value, we're able to estimate how much an individual feature contributes to the classification task, and we see that the hard emergency feature contributes the most to solving the classification problem. Both the primary diagnosis and the hard emergency features appear in this top ranked solution. We are also able to highlight interesting solutions to focus on them. We are able to reset the dashboard after we've done some highlighting, and we're able to also filter solutions based on the size of, based on their size. In the demo, we would have up to 10 data sets available for the participants to experiment with and answer the questions that we've raised in the previous slides. Thank you very much for your attention, and see you soon.